Welcome. This is our fourth lecture on computer organization. Today we will see what is data path architecture. In the last few classes we already seen what is called the instruction cycle and how instruction cycle consists of the different machine cycles, and machine cycle can be divided into different states. And here we will see a particular state will be execute in a single clock pulse, and state means RTL, that's mean register transfer level instruction. And to understand the RTL, register transfer level instruction, and how control signal actually set the path within the CPU to execute this RTL instruction, that's the micro level instruction, that will be clear if we understand the data path architecture of the computer system. We already know that the processor is built of some important components. One component is LU, another component is the controller, and there are so many registers. In the last class we already discussed what are the different registers present in the CPU. Now today we will see the different different multiplexer, LU, and the different registers, how they are interconnected to set the path for execution of the micro instruction within a CPU. Before that, we have to understand one important digital circuit, that is called the multiplexer. So suppose this is a multiplexer, it will have the multiple inputs, and with basis of this control inputs, there are some control input, and on basis of this control input, any of this data input will become as the output of the multiplexer circuit. And the diagram of the multiplexer is written like that. Suppose this is a true data input A and B, then this is the control signal, and this is the output of the multiplexer. And if you look at the LU, suppose one arithmetic logic unit is consist of 16 arithmetic function and 16 logical function. That means total 32 operation can be done in an LU, arithmetic logic unit. And here suppose these are the two data path, data A, data B, and it may be the different size. Suppose its size is 4-bit, so that's why this LU is called 4-bit LU. If the size of this data is 8-bit, then it can be called 8-bit LU. And as there are total 32 functions, so that's why 32 equals to 2 to the power 5. So that's why there will be 5 control signals. These are the 5 control signals. These 5 control signals will generate any one of these 32 functions that can be performed by the LU, and on basis of the data, the output also will be get. So these are the two important components that will be used in our data path architecture, and beside that we will use the different registers. So let's see how they are interconnected. So these are the registers. First register is instruction register. We know that instruction register when the CPU fetches the instruction from the memory, that instruction will be present in the instruction register. Then address register. Address register means when the CPU will generate the address and searching the memory for fetching the data or instruction, that address will be present in the address register. And there will be so many data registers. I mentioned here only 2 data register. One is D1 register, another is D2 register. That means these two are here data register. And there is another important register that is called PC, program counter. Actually, when CPU will search for an instruction, the address of that instruction will be present in the PC. So from this PC, the instruction go to the address register, and from the address register, that address go to the address bus. Now suppose there is a multiplexer, and now if we choose this path, suppose there is a multiplexer A and B. On basis of this control signal, any of this can be choose as the output. Suppose there will be some control signal such that means the output of PC will be go out from this multiplexer, and it go to the LU, one leg of the LU. So suppose this multiplexer control signal may be 0 or 1. On basis of 0 or 1, suppose when it will be 1, the B will be go to the output, and when it will be 0, the A input will be go out, as the output from this multiplexer. So suppose at first this program counter hold the address, that address go to the multiplexer, and by the proper control signal this address will go into the output of this multiplexer, and that will be go into the ALU part. And then this ALU, from this ALU either any of this input can be go out as the output, otherwise some operation. So it also you can consider it maybe the 32 operation can be done by this ALU. So that's why there are 5 control signals, C0, C1, C2, C3, C4. All these are the 5 control signals. Suppose there is an control signals 0, 0, 0, 1, 0. So on basis of this control signal, suppose whatever the value will be come in this B leg, that will be come as the output. So here this multiplexer, from this multiplexer again it has 2 leg and one control signal 0 or 1. On basis of this control signal either this A or B will be selected and go to the output. And suppose this is the data bus, that's mean from the CPU the data can be go out from the CPU, otherwise sometimes data can be go into the CPU also. So when CPU will access the data from the memory, then that data will be go out into the CPU, and when CPU will generate some data, that also can go out from the CPU. So now at first, so this is the data path of within the CPU. Now why this data path is very important? To understand this data path, let's see the different states. Last few classes we already discussed one machine cycle, how we can expand one machine cycle. So one machine cycle, we expand one machine cycle into the different state. So T1, T2, T3 and T4. So all these states, what will be the functions of all these states we already discussed. So let's see in the first state what will happen. The address will be put on the address bus. So that's mean PC counter. So address will be put on the PC counter. So that's mean the address that will be stored in the PC counter. From this PC counter the address will be put into the address bus. So this is the instruction that will be execute in the first clock pulse. So let's see what will happen. So to execute this one state, how this data path will help and how the control signals will be required to perform this particular state, one state. So let's see. At first this address will be put on the PC counter, PC register, and every register will have 2 control signal, in and out. If something will go out from this register, that out signal will be on. In something will come into the register, then in will be on. So when it will be out, that's mean when the address from the PC counter go out, then it will be going to the multiplexer, and suppose on that case the multiplexer control signal will be 1 for choosing this address to as an output. So in that case this control signal will be 1. Now suppose whatever the address will come, that should be go out from the ALU. On that case, suppose the instruction, the control signal will be 0, 0, 0, 1, 0. So all these are nothing but the control signals. So your controller will generate this signal on, and this signal, all this will be the signal of the ALU. Then that particular address will be going to this path. So suppose in that case again the control signal here will be 1, and then that data will be put on this line, and it will be go to all these registers, and ultimately it will be going to the address registers, in this address register, and when it will be going to the address register, that's mean the in signal of this address register should be on, and when it will be go out in the address bus, then the out signal should be on. So the in signal will be on, the address will be put on the address register, out signal will be on, the address will be go out from the address register, and it will be placed in the address bus. So in the first state, what is the operation? Operation is to put the PC signal address to the address bus. So to generate this to perform this operation, what will be the different control signals will be generated. So if we write all the control signals here, then what will happen? Suppose here what are the different control signals? The instruction register will have two control signal, okay. Then one in and out. Address register has two control signal, in and out. Data 1 register have two control signal, in and out. Data 2 control signal, data 2 register have two control signal, in and out. And then PC counter also have two control signal, in and out. This multiplexer 1 have one control signal. Then LU have 5 control signal. So this LU have 5 control signal, 1 2 3 4 5 control signal. This multiplexer, that means second multiplexer M1 have one control signal. Got it? So here put in this first state, what will happen? This PC out will be on. So that's mean PC out, this will be on, this will be 1. Then multiplexer, this control signal will be 1, so M0 will be 1. Then this will be 0 0 0 1 0, so this will be 0 0 0 0 1 0. And then M1 will be 1, so the M1 will be 1, and remaining all these signals will be. And then arithmetic address register, this will be, in will be on and out will be on. So address register, it will be on, that's mean in signal will be on and out signal also will be on. And the remaining, all other remaining signal will be 0. So this will be, all other remaining signals will be 0. Clear? So this becomes a control signal. So this is the control signal for the first state. So suppose you have a memory, so you can put this control signal into some word. So this way, every state will have this kind of control signals, and you can put all these control signals here. So for an particular instruction, there may be the different machine cycles, and every machine cycles can have the different state, and every state have this kind of control signals. So as a whole, if we collect all these control signals in a single memory, then it will be the whole control signals of the whole instruction of the CPU. So this is the, so to generate these control signals, so this data path is required. Why? Because for executing any particular state, the controller will produce these control signals, will produce all these control signals, and then the proper circuit will be on to perform this RTL. This RTL means this particular RTL, that's mean register transfer level or micro instruction. So to execute this micro instruction or this RTL or this state, the controller will generate these control signals, and these control signals actually set the path, and your path will be, this will be that particular path. So path will be this. So the data will be go out from here, then it will be go here, then it will be go here, then it will be come here, then it will be come here, and then it will be come into the address register, and then it will be go. So by setting all these signals by the controller, this particular path will be on, and the one particular instruction state will be executed. To execute the another state, there will be another set of control signals generated by the controller, and the different type of path will be set, and that particular operation will be done. So this way the controller will generate the different control signals, that's mean the micro instructions, and this way the different state will be executed by the CPU and your instruction will be executed.